Okay, so this is the March meeting for the Cloud Native Jenkins SIG. And on the agenda, we have Jishen talking about Azure storage, an introduction to Jenkinsfile Runner, and comments on the serverless Jenkins with Jenkinsfile Runner on AWS Lambda and Project FN. And I guess we can start. See, I'll make you presenter.
Okay, I will share my screen. Can you see my screen now?
No.
Hello?
No, I can't.
I can.
Yes.
It worked, right?
Yeah.
Okay. Hello, everyone. I'm Jie, and I'm from Microsoft. And today I will share our implementation about the external artifact storage for Jenkins. It is the JEP 202. And first, I will talk about our design about this plugin. First, we choose to develop an individual plugin aside the Artifact Manager S3 plugin for since the plugin name is not suitable for Microsoft Azure. And we also didn't choose the JClouds just to decrease the complexity of our plugin because Azure Jenkins team will take care of maintaining all the Azure related plugins of Jenkins. So we just don't need the JClouds here. And because previous we have a storage management plugin for Azure in Jenkins called Windows Azure Storage plugin. It can upload and download artifacts to Azure storage services. So in this plugin, we just choose to reuse the plugin to finish the uploading and downloading job for us. And to make the Windows Azure Storage plugin to be compatible with the JEP 202, we have made some changes to the plugin. First, the plugin used cannot upload artifacts from the agents. So we have changed the class. We choose to extend the master to slave file callable class to make it be able to upload some artifacts from the agents. Also in the JEP 202, one mentioned the security problem is that we shouldn't pass all our permissions to our agents. So we also choose the SAS, also called shared access signatures, which will give limited permissions to agents, like maybe only be able to uploading or downloading artifacts. So I will do a demo with the new plugin here. Oh, first, do you have any questions about the design? Okay, then I will go with the demo.
Sorry, I just wanted to ask whether, from what I see, it's a common implementation of Artifact Manager API, right?
Yes, we just implement some interfaces from the Jenkins core and the workflow plugin.
Yeah, so, yeah, thanks.
Okay. Let's do the demo here. First, we can go to the Jenkins configure system here. And in the artifact manager for builds part, you can add Azure Artifact Storage to manage your artifacts in Azure Storage. And after you add one, you will see a table like this, and you can choose different storage type. But for now, we just support Azure Blob Storage, and maybe we will implement some like Azure File Service, like this other storage type here. And then you can choose your storage credential, and it will authenticate with Azure. And here is a little similar with the Artifact 3 S3 plugin. You can choose a container name here, and you can also provide a base prefix for your storage container. And once you have finished this setting here, and you can create a easy job like Artifact Manager here, and we can see the configuration of this Artifact Manager project. I just do a very easy demo here, and first I will create a file, and I will stash it to Azure Storage, and I will do some modification to it. I will delete the file and make a subdirectory in the folder, and I will also use the directory command to unstash the stash file I have stashed before, and finally I will archive all the artifacts here. And let's run this job. This log will also get some logs from the Windows Azure Storage plugin, and it will also print out some messages like stash the file to our container, and it will also unstash the file from our archived file, and also upload the finally artifacts here. And let's go to the Azure Storage. And first I have choose to go to the blob named demo, which it is the same as the configuration of Jenkins. And you can see the base prefix SIG here. And in the SIG folder, you can see it is the project name of our Jenkins job. And in the job, just we have run a job, and it is 29. You can see also in the Azure Storage, we have a 29 folder here, and in the folder we can see the target artifacts, and the subdirectory here, and the file I created. And to test the virtual path here, I will choose to delete the job here. And you can see the folder of 29 is also be deleted from the Azure Storage, and it is consistent with Jenkins master. That's all. Any questions?
Do you have a demo showing the upload from an agent? Does it work the same way as well?
Oh, I didn't set up agent here. It will take some time, but I have tested it and it works well. Any other questions?
Yeah, also I wanted to know what kinds of automated tests you do for this, and how you develop this in terms of testing, and what different kinds of situations you test it against.
First, I write some unit tests, just like the artifact managers S3 plugin, and I have covered all the scenarios in that plugin. And I also do some integration tests with Azure Storage, like I have set up jobs like create some files and stash it and unstash it and archive it, and also do some deletion and also copy the artifacts from jobs between different jobs like this. Anyone had any other questions?
Yeah, so for credentials, I don't know, in Azure you can also use like instance profiles or something like that, so the credentials are not stored in Jenkins, or that's not possible?
Okay, so credentials, right? For the credentials, here we just support one credential type, which is implemented by ourselves, and you can only choose the Microsoft Azure Storage credential type here, and you can provide your account name and account key to authenticate with the Azure Storage. You can only support one credential here.
Okay.
I have a question. Can you provide a filter for the credential list? Maybe no one will know the exactly type of the credential. Do you have a help file to describe this?
Yes, you can see some easy information here, and maybe we can enhance it. And indeed, if you have other type of credentials, it will not list here, and it will only list the storage credential here.
Can we implement the when we click the add button, there is a list of the type. Can we filter this list?
It will default use the Azure Storage account, right?
Yes, can we just leave this alone?
Yes, I think so. I will do some changes to make it happen.
Okay, no questions. Thank you.
Thank you. Any other question here? Okay, then.
Sorry.
Go.
Can we provide? Can we create a multiple provider for the architecture to upload? More than one?
You mean several containers like here, right? You may want to upload two different containers at the same time of your job, or like you have several jobs and you want to upload to different containers, like these scenarios, right?
Maybe the two use cases all exist. I just it's an open question about this.
Yes, I agree with you. But for now, this plugin cannot support that scenario, and I think maybe we need some changes on the Jenkins core side, right?
Yeah,
to provide a variable to define the different containers.
The idea of the Artifact Manager API was to have one backend for the whole Jenkins master. So you don't have to do anything in your jobs to just use it. If you want to upload to multiple containers, then you would use a plugin with pipeline support where you could just say, upload this to this container, upload this other file to other container. But for this is what the APIs was made for. This way, you don't have to change your pipelines at all. All your artifact storage is going to go to a blob storage and is not going to go through the master.
Yes.
I wonder maybe we can offer a filter to match the Jenkins job and the storage. Maybe we have a better solution. It's just a simple offer.
Well, if somebody wants to, they can always have they can always define a special artifact manager factory which lets you define a folder property where you set a different artifact manager factory for all of the jobs within the folder. And that wouldn't require any changes to Jenkins Core or any other plugins. It would work with S3 or the Azure storage equally. But we didn't see any particular need for that, at least while developing the S3 version, because the intention, as Carlos said, the intention was that the storage is basically transparent for users of the Jenkins server. So it's intended to be something that the administrator configures with just a big enough area and sets up the credentials, and then users don't have to think about it.
Yes, I agree with you. The Jenkinsfile pipeline should be transparent for the storage. If we have another way to let the different pipeline upload to different storage, it will be great, I think.
Cool. And other questions we should talk about?
How about write some ideas to the document? Let the discussion be more effective.
Okay, so you need to take some notes here, right? Okay, and I also have one question about Cloud Native SIG. Does this page always updated? I'm a little confused here since the content seems a little updated here.
Yeah, so if you want to put references to particular implementations, feel free to propose a pull request to this page. So the entire Jenkins IO is managed by pull requests, and everybody can do that.
Okay, so the part like jobs still haven't started, right?
What do you mean?
Yeah, it's not up to date, I don't think. There's some things that says in progress that are no longer in progress.
Okay.
But the things that are not started, they are probably correct.
Okay.
Yeah, that's right. So there are some research work. There is also some pull requests and implementations, for example, .ci, but there is not that there is no APIs in Jenkins core in pipeline for that right now.
Okay. That's all. Do anyone have any other questions about the artifact manager?
Okay, thank you, G. That was great.
Thank you. So I will stop sharing.
And now, Oleg, you'll do the...
Yeah, I'll do the quick overview. We also have Francisco on the call. He is one of Jenkinsfile Runner maintainers. So yeah, I have the team here. Do you see my screen?
Yeah.
Okay, could you please make me a presenter so that it
Yeah.
gets proper to YouTube? Okay, I should really snooze guitar, but okay. So I'll just try to make a really quick presentation with demos. I think we already had a brief discussion of Jenkinsfile Runner at the special interest group meetings. Just to quickly introduce myself, my name is Oleg Minashев. I'm just one of Jenkinsfile Runner maintainers and Jenkins core maintainers. We have been working in Cloud Native SIG on this topic starting from June, I believe. We had a presentation together with JC and Carlos about single shot Jenkins masters. The presentation happened in September, I believe. And this introduction is just an overview of one of components we used in single shot masters vision. Okay, so what Jenkinsfile Runner does? Just quick thing, it's a single shot Jenkins master, which can take your Jenkins pipeline, execute it in a container in pretty much every environment, produce the results, and then terminate. So it's a single shot master thing we were talking about before the SIG meetings. If you have seen Shifting Gears blog post by TK, he had an overview of what cloud native Jenkins would look like. Obviously, the vision significantly changed since that times, but yeah, there are common things like having continuous scaling, having opportunity to run Jenkins as use, and being able to fastly develop the things and to apply it for custom use cases. And Jenkinsfile Runner was positioned as one of ways to achieve that. And when we talk about Jenkinsfile Runner, when we talk about Jenkins pipelines, I would rather talk about Jenkins as paths. So just a function which can be invoked. For example, you have a pipeline or a pipeline step, and if you want to execute it in your environment, if you were able to take Jenkins and execute that, it would be really helpful. And this is what Jenkinsfile Runner is about. Basically, it's just a binary or Docker image which takes your pipeline and executes it. And currently, it has access to workspaces, and it also can dump data to std out. Probably I should just show a quick demo. So yeah, if you want to run Jenkinsfile Runner, there is a sample command line. Currently, we don't host the Jenkinsfile Runner as an official Docker image, but later I'll show how to build it if you're interested. So yeah, I'll just switch to my command line. Is the screen big enough?
Yes, it's okay for me.
Yeah, so you may see that it's just one of the demos from Jenkinsfile Runner repository. So in Jenkinsfile Runner repo, we have several demos, and there are also demos in other repos we will be discussing. So if you want to reproduce it, you can just refer to this demo. There is make clean build command which prepares this demo. I won't touch it, but I will just execute it. So it's a common experience of Jenkinsfile Runner. You may see that there is Docker command which takes an image. It also takes a Jenkins file from provided path. Yeah, I'm running it on Windows with Windows subsystem for Linux with a few virtual machines. So it takes a while to just execute it. But yeah, if you take common environment, it takes just a few seconds to start up. And yeah, probably I should have disabled antivirus before running this demo. What's going on? Oh yeah, you may see that it's just microstalling visualization. So let's try again. What's going on? So yeah, it seems that there is some issues with streaming data. Oh, yeah, now it runs right. So you may see that it starts executing whatever pipeline inside. You may see that there is a performance optimized durability mode. It's just a message from pipeline ecosystem, because Jenkinsfile Runner includes lots of customizations to run fast. Well, if you run it on common environment, it's just less than 1 second to start up and execute this demo. And here you may see that it actually executes a few commands. It runs wget from whatever evergreen repository, then it uses pipeline utility steps. There is read YAML command, and it uses it in order to just print a Jenkins core version being used by evergreen. So if we take a look at this demo, you may see that this demo actually, here's our Jenkins file, which we executed. So it's a single stage thing which just executes 3 commands. But obviously you can do much more things with Jenkinsfile Runner. It's just a common engine where you can do many things. And later I will show a bit longer example of how it could be used. So let's just finish with overview. So Jenkinsfile Runner has a pretty long history in Jenkins means. It started almost 1 year ago. I believe that the thread has been started on March 13th or so. So probably it's time to celebrate 1 year of Jenkinsfile Runner. Yeah, originally it has been started by Kiki. He proposed it as an engine for pipeline test automation and also for single shot executions. Then it was enhanced by Nicola Belov, who also contributed a lot to the stability of this component, and who researched ways to manage configurations in various ways. Currently, Jenkinsfile Runner is in beta state, so you may see that it's beta 7. There was a number of releases since October when we switched Jenkinsfile Runner to common maintenance state. So it was hosted on Jenkins CI. We've got a number of maintainers. Currently, it's maintained by Evarista, Francisca, who is on the call, and by me. And we are working towards various enhancements and towards stabilization of Jenkinsfile Runner, so it could be consumed in various flows. So yeah, it's still in beta, but it already got a lot of adoptions. The biggest adoption is, of course, Jenkins X. They use Jenkinsfile Runner in the serverless mode. We had an overview of this mode also a few meetings ago. Then we have a reference implementation of CI Jenkins.io runner. So it's an emulation of CI Jenkins.io. It's Jenkins on Jenkins, which we use to test plugins. And we also packaged it to Jenkinsfile Runner just to showcase that. And there is also a lot of different packagings. So a few examples here, it's GitHub Actions, it's CodeShip, and also AWS Lambda and Project FN, which will be presented by Carlos today. So Jenkinsfile Runner got some adoptions, and yeah, it can be used in pretty much every environment. And how could you use it? One of the most standard ways is to just take something from the repository, and we have a Jenkins CI Jenkinsfile Runner repository. Currently, it provides a way to build a binary or Docker image. But as I said before, we don't really host this Docker image right now. There are plans to do it at some point. Yeah, the problem is that approach that packages only particular pipeline plugins. So if you want to run your custom pipeline, obviously it's not the best way to do that. And in order to work around that, we also offer a tool chain in order to build custom Jenkinsfile Runner packages. So this flow is powered by custom work packager, and it produces ready-to-fly Docker images. So this is just an overview of this flow. Yeah, it takes custom work packager, it takes Jenkinsfile Runner. You can pass whatever arbitrary configuration of Jenkins core versions and plugin versions. Then you can use Jenkins configurations, code plugin, or just standard Groovy hooks or system properties to pass configuration. And as an outcome, you get a fully packaged Jenkinsfile Runner image, which can start out of the box. So for example, if you want to take Azure artifacts which we discussed before. You can configure them via Groovy or JCask. You can pass credentials to this image, for example, using Kubernetes credentials plugin or something for Azure. You can pre-configure everything and bundle it in the same image, so you will get an instance usable for particular configurations. Together with Jesse and Carlos, we presented a flow for AWS with Amazon S3 and other components. I believe it was presented in September at the SIG meetings. So yeah, actually you take everything and package it as a single instance. And yeah, probably I should just show you an example of that. Who has ever seen this custom work packager flow? Okay, so I will briefly show it then. If you're interested to have more details, there is a link to the blog post. I'll post the slides later in the GitHub channel. But yeah, there is an instance. So this instance is actually managed by packager config YAML. So this is an input YAML file which manages custom work packager, and it defines everything here. So you may see that there is a pretty short configuration now because yeah, we pass plugins using POM.XML input. We also pass Jenkinsfile Runner using this definition. So you may see that we take a particular commit right now. Obviously, I should change it to a tag because now we have releases. I just didn't touch this component. And here you may see that we also take whatever base image in order to build on the top of it. We use it in order to have a specially built images for CI Jenkins IO. And if you don't like that, you can take a classic Jenkins image, for example. What else do we have here? We have some system properties, mostly for for configuring agents, which we use in sidecar containers now, and we optimize provisioning, and we configure instance using JCask plugin and Groovy hooks. So you may see that everything is packaged here, and after that you can just take Jenkinsfile Runner and custom work packager and build the image. So you may see that there is command here. It effectively just pass the configuration and everything is built. I won't be showing it right now because yeah, it takes errands to build it on a machine with Windows Defender. But yeah, on common machine, yeah, you will get it maybe in 30 seconds if you have everything cached. What else do we have here in this demo? You may see that yeah, I'm using POM.XML as an input. You may see it here. So all plugins are passed through POM.XML. There are a few reasons for that. Firstly, we use standard Jenkins plugin POM, so we get features like Maven Enforcer out of the box. And last but not least, we also get a Dependabot, so it's automatic management of dependencies, which is integrated in this release. So you may see that there is a bunch of incoming updates. And yeah, finally, if you want to try this demo, you may see that there are some samples. For example, if you want to build a plugin, there is a demo embedded here, and we just use a common Jenkins build plugin. So if you want, you can run this demo in order to build your Jenkins plugin in a single shot way. Yeah, if somebody is interested, I can explore, can talk about this demo more later, but I believe that Carlos will be presenting custom work packager flow or maybe other flows in his demos. So probably we could talk about it later. Okay. So before we go to the last section, are there any questions so far? Okay, no questions, I believe. Okay, so what has changed in Jenkinsfile Runner recently? So we have been talking about it since June, I believe. In September, there were presentations at the SIG meetings, but there was a lot of changes which happened recently. Thanks a lot to Francisca and Evarista who implemented the most of these changes. So firstly, we have a new framework for test automation, Jenkinsfile Runner test framework. It's been actively used in custom work packages, and we are adopting it in CI, Jenkinsfile Runner, and other components. Then Jenkinsfile Runner supports Java 11 now. It contributes a lot to features in the cloud. For example, Java 8 doesn't really integrate with C groups. So if you want to limit CPU usage or RAM usage, it's better to use Java 11. And you can run Jenkinsfile Runner with Java 11 right now, even though all common disclaimers apply. It just landed in GA in Jenkins a few days ago. Then, yeah, we did a lot of things to clean up the architecture. Before the patches, it was based on JUnit test rules. It had pretty bad performance in terms of initialization. It has been already improved a lot, and there are still lots of things which we could improve. And last but not least, we implemented some pipeline features integration. So now we map workspace to a standard location, so you can map it to volume. It's useful if you want to use Jenkinsfile Runner as a basic step, for example, in your pipeline. And now there are discussions about Tecton pipelines in Jenkins X, and yeah, Jenkinsfile Runner can be used there as just a step with workspace mapping, for example. Then you can disable sandbox if you do not like script security. Well, for Jenkinsfile Runner, it's probably not a case. So there are no security risks because it's a single shot instance. And yeah, if you want, you can disable sandbox in order to give more freedom to your users. And also pipeline parameterization, also the thing which was requested for a long time. And finally, it has been landed in the Jenkinsfile Runner master, and it's available in beta 7. What else? Yeah, we have a lot of integrations, and I believe that Carlos will talk today about AWS Lambda or Oracle FN. And yeah, if you have questions about other integrations, we can just talk about it later if we have time at the meeting. Okay, any questions? If no, you can find more information just by following these links. So there are some user guides, there is also architectural review, which you can use to get more information about the instance. But yeah, from the user standpoint, it's really simple. You just take the image and run Jenkins files. And as long as you have everything packaged properly, yeah, it will execute your pipelines. Okay, that's it from me.
Thanks, Oleg.
Yeah, I'll start sharing if I find the button.
Okay, so I'll share my screen. Okay. So yeah, what I did was a couple of proof of concept running the Jenkinsfile Runner on AWS Lambda and in Project FN. So you can see well, I wrote a blog post and there's a Git repo with the same information. So this basically allows you to run Jenkins pipelines on AWS Lambdas. It has a GitHub webhook processor, and it will receive this GitHub event, clone the repository, and execute that, the Jenkins file in that repo. And with all the benefits that Oleg mentioned, this could be interesting if you're building like AWS related things, like uploading and downloading things from S3. And this obviously doesn't support all the features on Jenkins files, but it's if you're doing something limited, that could work. The Lambda limitations is it can only take 15 minutes of execution time, 3 gigs of memory, and 500 megabytes of storage. So whatever you write into the file system and the Git clone can only take 500 megabytes. And yeah, there's a couple of things that I didn't bother to go through for now. For this proof of concept is checkout SCM doesn't really do anything. You need to clone the specific repo that you want, and you
So
have
that would mean that it checks out the current tip of the branch, which might be different from what the webhook was in response to, right?
Yeah. Mm-hmm. Yeah. I couldn't get checkout SCM to work. I guess there's some environment variables that need to be set for that to work. Or
it's a bit tricky, and it also requires proper initialization of payload in Jenkinsfile Runner. So right now it starts any pipe Jenkinsfile as standard pipeline. So probably you won't be able to emulate checkout SCM until it's fixed architecturally.
Well, this happens before Jenkinsfile Runner is called. This is just the function is here. It's
all right. So it's outside Jenkins as well at all.
Yeah. This is just a function that basically receives the request and parses the GitHub payload. And then here it gets the clone URL, and it's here. Yeah. Git clone will clone the Git repository, and then it will run the Jenkins file afterwards on that directory. So this Git clone yeah, would need to, well, I guess the run Jenkins file should somehow say something for checkout SCM to work. This
is doable, but it will need some patches.
Yeah, this basically runs the Jenkins file on that directory after the clone, passing the right properties for Jenkinsfile Runner to execute. And I'll talk now about the plugins, the structure, and things like that. You are pretty limited on the space and stuff like that. So I have an example that I tried. This is basically just a very simple Jenkins file with some executing Maven. As I said, you need to add user local bin to the path. You have to set the Java home. And yeah, this will clone and run Maven. And you have to use the user home, the temporary directory as user home for Maven to work. So Lambdas work with layers, and each layer is limited to 50 megs. So in this building this project, there's a makefile here. What it will do will create three different zip files, which will be the 3 different layers: one for the Jenkinsfile Runner, one for plugins, and one for Git, OpenJDK, and Maven. So if you want to use something else, you have to build it for Lambda and package it and upload it as a layer. And everything will be expanded into /opt. And if you wanted to do anything else like store artifacts on S3, then you would need to package your maybe configuration as code plugin, the artifact manager, and then the YAML for the config as code plugin, and then add that as a different layer. Yeah, I took some inspiration from the LambCI project, where you can find builds of GCC, Go, Java, etc. for Lambda and even Git. And then because basically you have to compile things, so everything is expanded in /opt, and all the libraries are in /opt, and so you have to recompile things to build those layers. Here I'm using Docker to build all that and create the zip files. Once you have the layers, well, you have to create a function, use the Java 8 runtime, and upload those layers to AWS. And you have to just set the handler to this, memory at least 1 gig. If you use the default, I think it's 500 megs, it will crash for now. And the timeout, you want to probably increase it to the highest, which is 15 minutes. You can also do it with the command line. And this would be to create the function. And yeah, the layers is a JSON file with the layers on. You can use the layers from S3 or upload them through the web interface. If you want the Lambda to receive the webhooks, then you also have to add the API gateway trigger. This is basically what is going to receive the webhook from GitHub and call your Lambda. Otherwise, there's no way to call a Lambda via HTTP. But if you want to have asynchronous execution, because you get the webhook from GitHub and then you want to return a success code to GitHub and continue the execution, you also need create SNS queue, simple notification service in AWS, and so have the API gateway to add something to SNS and then trigger Lambdas based on that. I didn't go that far because this makes it, it gets it complicated pretty soon, pretty easily. But that's how this asynchronous event execution is supposed to work on AWS. Building, polishing. Okay, so if I go to Lambda on AWS, I have my Jenkinsfile Runner function, runtime. So you can upload here the function code if you want. This is the handler that I mentioned. You need a role that allows you to store the logs of the Lambda function on AWS CloudWatch logs. So I think this was created from here, from the UI. You can set the memory, the timeout, and everything else is the default. On the layers part, this is interesting. So you have one that includes the Jenkinsfile Runner code. So the function only includes the code in this GitHub repo. So only the function code, the Java code for the function. Another layer that you get from the make file is the Jenkinsfile Runner. This is the Jenkinsfile Runner proper code. Then another layer with the plugins and another layer with the tools. So you can upload this from here, or you can here. No, wait. Oh, yeah, you can upload them from here, or you can upload it to S3 and then just reference from here. And here, the other thing that I mentioned, I have the API gateway that is receiving the webhooks and calling the Lambda, and then the logs from the Lambda goes to CloudWatch logs. There's nothing really here. This is just added, and I get the API endpoint where my GitHub trigger can be set to. And once this runs, so basically you do a post to this web to this endpoint. what you get, well, basically you get nothing pretty much, but what you see in the logs, you can go to the Lambda CloudWatch logs. So you have logs for each execution, and you see all the output from the Jenkinsfile Runner. So you get, well, and the function too. So there's some GitHub cloning, Git cloning, and then Jenkinsfile Runner is executed, and all these Maven downloads from the internet. And obviously, if you want to do this properly, you probably want to have a Maven repository in AWS, so this doesn't have to go to the internet every time. And you get a build success, and then it's finished here. What happens with Lambdas is that they get reused. So if you call the endpoint multiple times, very short amount of time, this gets reused. So this takes care of using different directories in different executions. What you may have or end having, you see here, it's not downloading everything from the Maven repo. What you have to take care of is if this gets called multiple times and causing downloads of files, then you're gonna run out of space. So it's not a perfect solution for everything. And I think that's it for Lambda. And then I took the same ideas and built the the same functions for FM project, which is this open source project for functions in Docker container. Well, yeah, you can do it in Docker containers. And you can run it on-prem or you can run it on cloud, so it's all open source. And the difference with Lambdas is that, well, the signature changes, the function signature. Let me go here. So the function is a little bit different, but not too much. If I go to the function handler, yeah, the request, it's a bit different, but the clone is the same, and running the Jenkins file is pretty much the same. So the big difference is the packaging. Lambda layers are limited on size, and things are getting expanded in /opt, but FN allows you to just provide a Docker file where you can install whatever that you want. And you can see that here, this Docker file. So what I'm doing is I'm getting Maven. This is a multi-stage Docker file. So I'm getting Maven, I'm getting the Jenkinsfile Runner, I'm getting the plugins that I want, I'm getting the Project FN utilities, the FDK, what they call. I'm getting the OpenJDK 8, and on top of that, I'm copying Maven, the FDK, and Jenkinsfile Runner, and the plugins. And then I'm just using the FDK entry point, just passing the right parameters. I copied this from their Docker file, and the command is just my function handler. But yeah, everything is in one Docker file. You build a Docker image that works with Project FN. You don't have to do all the stuff that you need to do with AWS Lambdas. And I tried this both local and in Oracle functions, which is Project FN on the cloud. And this is a limited availability for now. less limitations that in Lambda. Check out SEM does not work, the same thing. And everything that writes files need to go into /temp. And that's pretty much it. You can install FN locally and try it with, you can create the application FN create and then deploy it. And then you can just send via standard input your GitHub payload and invoke the function with that and get the logs of the last execution locally with FN get logs. The interesting thing with Project FN is that they tell you that if you want to see the logs in the cloud or somewhere else, you need to install a syslog server, and you can do that locally with Docker. But basically, they are not providing a great way to see the logs. You have to send the logs to syslog. And I think it's Papertrail that offers you syslog on the cloud. But yeah, you have to send the logs to somewhere. And that's it. Do you have questions?
What's next for these prototypes?
Nothing so far. I guess it's just, I don't know how useful they can be. There's definitely Lambdas can be interesting for if you have a Jenkins file and you want to run it on AWS, and it's simple enough, and it doesn't take 15 minutes, more than 15 minutes, you could do that. The problem with AWS is kind of a bit complex to set up things. So the benefits you may get must be higher than the time it takes you to configure everything.
Yeah. What is the benefit being compared to Jenkinsfile Runner on Kubernetes? Because if you take Kubernetes, you can achieve pretty much the same just by using Kubernetes ecosystem. It should be more portable.
Well, yeah, obviously it's more portable than Lambdas. What you get with Lambdas is the serverless part. You don't have to run anything. You don't have to run a server. You don't have to do anything. And you pay exactly for what you use.
Yeah, fair point.
So for something that you don't call very often, or for something that you want high scalability and it's simple, then it would be interesting. The problem is the complexity, and all depends on how many tools you need installed and everything like that. But you could have, I don't know, if you manage to package it, then you could have your projects built in Lambdas if it's like a small project that you don't build enough and just pay cents to do the builds.
Yeah, that's right. So theoretically, we could also tweak customer packager or whatever to produce these outputs as well. But yeah, it would be a bit more challenging. Or yeah, you already have make files, so maybe they could somehow generalize.
Any other questions, or we can wrap up? Okay, well, thank you all for joining, and I'll publish the video and add the notes. I'll stop the broadcast now.